Hello subscribers and watchers, what's up? It's me, Vivs from slidenerd here. In this video, we are going to talk about the multi-threading architecture of Android. We're going to talk about some methods that we are going to use while making our sample thread application in the next video. In the previous video, I already started talking about this little beauty over here. And if you guys haven't seen it, please check out the previous video because otherwise you are not going to understand anything. So let's directly start with the architecture. For every process, what you have are internal components and external components that you have. Now, internal components are activities, broadcast receivers, services, and content providers that you make inside your app. External components are pretty much the same thing. Now, there's a main thread or a looper, and then what you have is a message queue where all the messages are posted one by one, and the looper runs the messages one by one. Like activities, broadcast receivers, and services post messages asynchronously on this message queue, which means you click a button on the activity, the on-click is executed as part of a message in this message queue. The on-receive method of your broadcast receiver is run here in this message queue as a message, and the service has its own on-start command that gets posted as a message here inside the message queue, and so on. The content providers work synchronously. They directly go to the looper and say, run my database query. They do not wait in queues. Now, this is something we talked about in the previous video. Now, when you talk about external components, for example, say someone from outside your app is calling activities and broadcast receivers. They are called on the main thread. However, for services and content providers, what you have is they are run on a separate thread. Now, when you say separate thread, there are several questions. Should I create a new thread for every service being requested by the external component? No. What your process does is it maintains a thread pool. Let's say there are 10 threads. Currently, if every thread is empty and it's not doing any work, then one of the threads from this thread pool is assigned to the external component where the service or the content provider is being run. If all 10 are busy, then a new request for a content provider or service by the external component is placed in the message queue of the external thread pool that you have. Now, I know that all this sounds pretty complicated, but trust me, this is 100% simple when we start working with the examples, and you will clearly understand what is going on so far. So this is the architecture of multi-threading in Android. So now let's take a look at some useful methods. The first one you have is this method called runOnUiThread, and it belongs to this class activity. It takes a runnable object. Now, most people think that runnable object means a separate thread. That's actually a wrong conception. Runnable object means some code, or you can say that is packed together, that can run. That's all it means. It doesn't mean separate thread or current thread or anything. There is no relationship with threads at all when you talk about something which is runnable. It just means a piece of code. So run the specified piece of code by this runnable object on the UI thread. That's what this method does. Now, if the current thread is the UI thread, then it's executed immediately. Otherwise, it is posted as a message to the looper or the message queue of the UI thread. So you can use this method from a background thread to update your UI, like a progress bar or a progress dialog or something else that you guys have in mind. And we are going to see how to do this in the next video, so don't worry too much about it. The next method that we are going to talk about is the post method. Now, this belongs to the class view over here. Again, the same idea that there is a runnable object. If it's the current thread, run it immediately. If it's not the main thread, then post it as a message to the message queue. The boolean indicates if the message was successfully placed into the message queue. However, the boolean does not guarantee that the runnable object was executed successfully by your looper. Now let me show you why. Here is a more advanced version of the method post.delayed. Here is a more advanced version of your method post.delayed that takes a runnable argument and a number of milliseconds, after which it should process that message. Now this causes the runnable to be added to the message queue. Now the runnable will be running on the user interface thread. It's the same thing that you guys have been seeing so far. Now if it returns true, that means your message, that is the runnable object or the code inside the runnable object, has been placed into the message queue. It returns false on failure because the looper processing the message is exiting. Now think about this, that you call post delay from a background thread, but before your user has a chance to process that message with the looper, you exit the application by pressing the back button, which means the activity is destroyed. With the destruction of the activity, the looper is also destroyed, and hence the post delayed won't be run, and that means you will be getting false inside this code if you check it later when you come back to your application or something like that. So this is the basic concept behind post delayed and run on UI thread methods. And of course, last but not the least, here's another method that belongs to the class process, which is called setThreadPriority. Now the lower numbers indicate higher priority and the higher number indicate lower priority. Of course, that sounds weird, but then that's how things work in Linux. So -20 is the highest priority and 19 is the recommended process by developer.android.com is to call process.setThreadPriority right inside your run method of your thread with thread priority background. Again, if this is not clear to you, don't worry. In the next video, when we work out our example, you will exactly understand what I'm talking about and why we're doing this. The reason why we're doing this is to reduce the resource competition between the runnable objects thread and the UI thread. Like right now, what we have are two threads. One is the main thread, other is the background thread. On a single core processor, both of them are going to compete with each other equally to get access to some resource if both of them need that resource. However, we want to ensure that the competition is reduced for the other thread compared to the UI thread, because the UI thread needs to perform more important tasks, and hence we are going to give thread priority background to the background thread that we have other than the main thread. Now this is for single core processors. For multi-core processors, obviously you don't have to worry much about this, but then since you design your apps to run on any mobile device, you should consider even for a device which has just one processor and target your applications that can run even on those older devices. So now that we have talked about that, let's talk about how a progress bar is actually updated from a background thread. So let's say I have an activity, and let's say there is something over here. There's a progress bar, I simply find it. Now let's say I'm downloading something, and that code is over here by this dot dot dot, which is actually performed in a separate thread over here right in front of your very eyes. Now this is a worker thread. This lets me download an image from the internet. Now while downloading the image, I want to update the progress bar. I cannot directly do that because the UI thread has access to the activities UI elements and the view hierarchy that is being constructed when the activity is initially loaded from XML. The background thread does not have access to that, and even if it does, it simultaneous modifications by the activity and the other worker thread will make your UI run messy and buggy, and hence you don't want to do that. So what we do is we use one of our methods like runOnUiThread or post delayed, where we publish a message. Now this is the main thread's queue over here. So when I say p.post, I want to, let's say, update the progress bar value. So I call progress bar object.post over here, and this is gonna take a runnable object inside which I will set the progress. Now like I said, this runnable object is simply a message posted on the main thread queue. When the looper finishes running the first aspect, it's gonna come here, run this runnable object, it's gonna update the progress. In other words, from the background thread, the progress bar is updated on the main thread, but the work here of downloading the image takes place on the background thread. So we are gonna take a look at this example in the next video and work this out. So let me just give you a rough hint of what our example will do. What we have is some kind of app which has different URLs over here. These are image download URLs. So when I click on one of those URLs, that will be popped up here in the edit text that I have. So there's a download image button. When I click on this button, remember the URLs are constructed as part of a list view which belongs to the main thread. But the download image act work will be performed on what you have as a worker thread or a separate thread, from where it will connect with the data source at URL3. With the help of an input stream, it will read the data, and while doing so, with the help of the post message or run on UI thread, it will be constantly sending messages to the main thread to update the progress bar while the image gets downloaded. So this will be the sample application that we're going to work out in the next video. In the meantime, if you guys like what you saw, please like this video, share this video, subscribe to our channel, and let us know your thoughts in the comment boxes below. Thanks for watching. We'll catch you guys in the next video. Have a nice day. And for any queries, please post it on our official Android programming group on Facebook. See ya later. Bye folks.